Right. So we are going to discussing about a topic called as linked list class. So the same book we are going to following, the Java complete reference, the 9th edition. And coming to the topic. Now this topic is going to dealing with same as the hierarchy of our framework. What is the hierarchy of our framework is from iterable to the collection. From that it is deriving the list concept, right? So iterable, collection to the list, and it is coming to the abstract sequential list and coming to the linked list. Like this, it is deriving from the iterable to the collection to the list to the abstract sequential list to the linked list. Now this called as interface, collection is also called as interface, list also called as interface. Now in this color, abstract sequential list is a class, linked list is a class. So class linked list extends abstract sequential list, which is going to be implements list, which extends collections, which extends iterable. This is the hierarchy. Now, what is the use of the array list and linked list? Is array list already we have discussed that is a dynamic in nature. Array is normally static in nature. Linked list is the way you are going to be connecting. How you are going to be connecting is nothing but see. We have seen an example here. So when you are considering a array, an array can be stored in a index manner like this. It will store like this: 0, 1, 2, 3. This is the index. In the form of index, it is going to be stored in the array list: 0, 1, 2, 3 like this. Whereas this is called as array. Whereas if you are going to be consider an list, means linked list, when you are considering as a linked list over here, so this linked list will be considered as like this. The list will be stored in the form of a, this is the list, linked list. Normally it is going to be stored as a list format. List format, it is going to be stored. Each element will be stored in a list. So this is, it is going to be storing in the form of list. Okay, that is only the difference between array list and linked list. Now coming to the topic, Java LinkedList class uses doubly linked list. Doubly linked list in the sense we can make from the first side, that is from front, we can insert the elements. From the end, means from the last also we can insert the elements, or we can remove the elements. We can insert or remove the elements from both the ends. Not only this end, from both the ends we can be use this one. Okay, so this direction, not this direction, this way we can insert from the end, and we can also insert at the starting. From both of the ends we can be do this one, right? So that is the beauty of the linked list. From the starting and from the end, wherever the end we can insert that. So from the last or from the first we can insert or we can delete the elements in the list. Like we can add somewhere in the positions, like with the help of the indexes in the array list, we are going to be adding, right? In this linked list, we are going to be in the double linked list format. This list will be stored in the double linked list format, means from both the end, from starting of this end, starting, and from the ending, from both the ends, we are going to be add the or remove the elements. Okay, that is the meaning here. Double linked list, to store the elements, it provides a linked list data structure. So linked list data structure, it will provide it inherits, already we have discussed about this one, it inherits the abstract list class and implements list and deque interfaces. So these are the two interfaces they can be used. Now coming to the uses, the important points in the Java linked list is it contains, similar to the array list, duplicate elements. It maintains the insertion sort similar to the array list. It is also not synchronized, similar to the array list. We can just in Java linked list class, we can manipulate is a fast, where in array list is a slow. Why? Because if you change any element in the middle of the element, say for example, a array consisting of 10 elements, if you remove a of 5, the element a of 5 you have removed, then at that time the shifting of that elements is, because of that, it is a very slow, where the manipulation here is a fast one, because no shifting is needed to be occurred, because it is storing in the form of a list. Now each element will be stored in the form of a list itself, linked list itself. So wherever you want, you can remove that particular element. Directly you can insert wherever you can just connect it in the form of a connection. We can use it like this list is going to be connected to this. This list is going to be connected to this one. Wherever if you want, you can just, if you want to remove this list, you can remove this. Wherever if you want to be insert another list, you can add one more list. So a list consisting of here the node means the address and the value. This is the value and this is the address. A list consisting of address and a value. Address is nothing but what? The current, the address which is there for this one, and the starting of the address and ending of the address. Starting address and ending address. So with the help of these addresses, we can insert or we can remove at the starting or ending. Or else simply we can make it as a list of 0 element, list of 1, list of 2, like this we are mentioning. So that's why every element it is going to be storing in the form of a list itself. So each it's consisting of some set of nodes. Here this is a node 1, we can call as nodes, node 1, node 2, node 3, like this. So each node consisting of the starting address, the value, and the ending address. Ending address means what? Pointing to the next list. It is going to pointing to the next list. But no need to worry about that addresses, starting address and ending address as part of this concept. Just remember a list consisting of a set of nodes, each node consisting of the address and value. So it will be stored in the form of a nodes. That's why if you want to remove or add, you are going to be removing entire node. You are removing or adding entire node where consisting of the address and the values, right? So because of that, it is going to be having a fast, because no shifting is required. Only pick that, like in the boxes, like similar to a boxes, simply we can pick that box, we can insert that box. Simply we can done that. And Java linked list can be used for list concept, stack, queue. In this concept also we can use it. So the difference between array list and the linked list is, here the array list consisting of store in the form of a array, whereas linked list will be stored in the form of a double linked list. Now they're also having duplicate elements, here also having duplicate elements, that also inserting in the insertion order, this also inserting in the insertion order. Array list also be a non-synchronized, the linked list also be a non-synchronized. We can manipulate the there in array list is a slow, because any element has removed, the shifting has taken more complex. But here manipulation is fast because there is no shifting concept, and we can implement there in the array list the concepts, like we can implement it, the hash concepts, or we can use the vector concepts there. Now here we can implement this with the help of this linked list classes. We can implement list, stack, queue, but we don't have the in the syllabus stack, queue, but you can learn in the data structures. No need to worry about that one. This is the hierarchy. Already we have seen in the starting of the figure how it looks like. Now the syntax. The syntax is already we have discussed that one, how it is going to be making sure from the hierarchy class linked list E, where E is nothing but what? The specifies which type of linked list you are going to be creating. Whether it is a string, whether it is an integer, whether it is a float, what type of list you are going to be creating. Extends abstract sequential list, where array list will be extends abstract list. This is abstract sequential list. Implements list, deque, clonable, and serializable. So these three are not in the syllabus. We can have these interfaces also, we can use it. And coming to the constructors of the Java linked list is, we have 0 parameter constructor and 1 parameter constructor. So we can create an empty list with the help of this constructor. We can create a set of elements specified with the collection in the order they written by the collection iterators. So we can create with the help of the set of elements, we can create this list also. And coming to the methods, like in the array list, we have a add. Here also we have a methods like add the index object element. So add of 1 comma a in the double quotation a. So a will be added in the first position. The same we can add here. So insert the specified element at the specified position, index in the list. So add first. If you want to be adding at the starting, you can use this method, add first. Add loss. If you want to insert at the last, you can use this. To know the size of the list, you can use size method. What is the difference there and this? We have 2 more methods, add first, add loss. So this also we can use, or with the help of index also we can add wherever we want in the list. Not only at the first, not only at the last, we can also insert in the middle wherever we require. That is the methods are available. Coming to the program, I am going to be just for a demonstration. I'm just discussing of this program. Here it is a Java util package we are importing, and we have a class linked list demo class we are creating and calling the main method. Now, how to create the linked list? Linked list, L capital, L capital. What type of linked list I am creating? String type of linked list. So what is the object name here? L1 and new linked list string. So we have created a L1 linked list string object. Now, how to add the elements? L1 dot add of F, B, D, E, C, Z. Add first. Initially, what is the first element? F. Now, what is the first element? A. Add 1 comma 2. Initially, what is in the first position? B. At that move at the position of B, going to be move the B element and add A2 at the first position. Now, original list we can display here. So what we are doing here, we are creating a list, we are adding elements to the list and we are displaying. If you want to remove the elements, we can remove directly with the help of the index. Directly we know the element, we can remove, or with the help of the index, we can remove. After removing, what is the list elements, remaining elements are available, we can display here. To remove the first and last element, we can just use remove first, remove last. And after the removing the first element, last element, now display the list. And we can get this on the element at the second position and we can assign. How to get that elements? We have a method called as get. Now, whatever the second position element you are getting and store in val, we can also set that second position, the second element we can get it. What is the syntax for get? Get of index. How to set the elements? Set of the index number followed by the second parameter is a value. What we are doing is whatever the second index element is considered, that will be stored in val, and we are setting to the second position that val value plus adding changed string. Whatever the value is there at the second position, that plus change. For that, we are adding this one. Now, after change, we are displaying L1. So this is the program, how we are going to performing, creating a list, adding the elements, removing with the element itself, or removing the index, removing the first element, removing the last element, get the elements, set the elements. That is the program, whatever we have for this array linked list. Sorry, this is linked list, normal linked list over here. Now let me see run the program. Now let me run the program so that you can understand very clear about this. Let me run the program. I'm just going to the program to execute this one. Here is the program. So linked list demo. Here is the program. Okay. See, linked list. We are using the main, and we are creating a list here, and we are adding F, B, D, whatever I have just now explained. And original list, we are removing F and second position, and after that we are displaying the elements, and again remove first, remove last. Again we are displaying the list of elements. Again we are get the second position, add the change to that and display. Now run the program. I'm just going to the command prompt from here, going to the CMD. Now what is the program name here? Linked list demo. So Java C space linked list dot demo dot Java. You don't have error, run the program. See, initially what you have said, the output of this program will be look like, right? The output of the program is A2 F B D E C Z. This is next. It is going to doing. Next is after deleting L1. What is the output? A2 D E C Z. A2 D E C Z. Now we perform first and last. A2 D E C. A2 D E C. As I said you, in the val there will be E, and for that E we are adding changed string. After that, the last, when you are setting the element, the output is A2 D E changed C. Okay, this is how it is getting. The commas are there, just I not put the commas over here. This is the output of that program. Okay, so that's about the link. So what we have discussed under this is, we have discussed about the linked list concept, we are going to talking about difference between the array list and linked list. One major difference is the manipulation is very slow there, and this is fast. There we are implementing with the array concept. Here we are implementing with the double link concept. And this is how we are going to be extending. And there we are extends abstract list. Here we are extend abstract sequential list. There we have only add, but here we have methods called add first, add last. Okay. And this is one demonstration. This is the output of this program. Okay. That's about the linked list concept in collection frameworks in Java.